So we are going to talk about the performance which is required for the certification of an aircraft, that is the airworthiness certification of the aircraft. So whenever we operate an aircraft, it is considered that the critical engine will fail at any stages of the flight. So now, once the critical engine fails, the aircraft has to achieve a certain minimum performance which is required. That minimum performance which is required to be achieved, okay, for certification of aircraft is what we call it as a mandatory performance. So mandatory performance is that performance which is required, okay, for certification of an aircraft. So with one engine failure, the regulators requires that any aircraft which comes up for certification has to achieve a certain minimum standard. That standard is what we call it as a mandatory. So now let's take an example that one manufactures an aircraft and they bring this aircraft for certification to any regulator, that may be EASA, FAA, or any of these things. So this company has to demonstrate it to that regulator that the aircraft is able to achieve the minimum mandatory performance. So there is going to be a lot of demonstration flight. Okay, so let us say that one particular test pilot flies a demonstration flight on a particular day that is under different temperature, pressure condition is going to be there. So on a particular day, if that pilot achieves a certain performance, and if we plot it, and the plotted performance is, let's say, like this dot here given. Now on some other day or some other hour, that means when the environmental condition changes, even though he takes up the same aircraft and it is being flown by the same pilot, he will not be able to achieve the same performance because of the variation in the weather conditions, that is temperature, pressure, density, etc. So he may achieve a performance like this. Similarly, considering all the other environmental factors constant, instead of flying one particular tail number or MSN number of an aircraft, if he takes another MSN number of the same aircraft, airframe and engine combination, then also the same aircraft combination kind of, then also even though they are the same family of the aircraft, two individual aircraft will not behave the same and that they will achieve a different performance parameter. So now let us plot that performance like this. Okay, so if I fly today and if someone flies it, because of the variation in our flying technique, different pilots, different flying technique, weather conditions same, aircraft same, even then I will not be able to achieve the same performance. So if multiple people fly multiple aircraft and on different days, and if we plot the performance of each and every individual aircraft can be plotted like this. They will not be the same, okay, however their performance will not be that far apart also, because they are the same aircraft, engine and the airframe combination, the pilot, flying technique. Even though it is different, there will be not of a very great difference, am I right? So it will be distributed like this. So now if I take the average performance of this entire fleet of the aircraft, that is the average performance of the entire fleet of the aircraft, that entire fleet is what we call it as a gross performance. This gross performance has to clear the minimum mandatory performance which is set by the particular regulator. So the gross performance, it is the average performance of the entire fleet of the aircraft. This gross performance has to be above the set minimum which is required by the regulator. This is part of a mandatory performance. Now let us think of a stage where I have lost one engine, that is a critical engine. The biggest threat on us, that is the aircraft as well as the human being which is there inside the aircraft, whenever I lose one engine is an obstacle. What if some obstacle comes up? Will I be able to clear that obstacle? So now let's put an obstacle here in this particular diagram. So let's say that this is the obstacle. Okay, this is the obstacle. So I need to clear this obstacle by my flight path, by a required regulatory margin. Yes, let us say that this is the required regulatory margin, and let us assume that the gross flight path is able to clear the obstacle by the required regulatory margin. But however, if I consider this particular individual aeroplane which was operated on a hot summer day by a relatively inexperienced pilot, and if he's able to achieve this flight path, then this flight path on this particular day will not be able to clear the obstacle by the required regulatory margin. So therefore, I am required to give a certain percentage of safety considering all these variations. That variations are those that aircraft will perform differently on different days because of the change in the weather conditions. The aircraft will be, no aircraft, two aircraft will behave the same, even if they are made up out of the same engine and the same airframe, because each and every aircraft has got their own characteristics. So therefore their performance also is going to be different. And also different people flying these aircraft may fly the aircraft with a little difference, so therefore the performance is not going to be same. So during the certification itself, I also have to foresee that one particular day this aircraft is going to get older and the performance is going to degrade, isn't it? If the performance degrade after a period of time, that also I need to look after. So in order to look after all these variations, I need to give a certain percentage of margin onto this gross flight path whenever I talk about this obstacle. So therefore, after giving this margin, okay, I will determine a flight path, okay, by reducing the gross performance by 0.8 percentage if I consider the takeoff stage of the flight, and in the en route phase of the flight, I will consider 1.1 percentage reduction onto this gross performance, and derive a flight path which is derived from the gross performance by reducing this percentage, and then derived flight path is what we call it as a, or the performance is what we call it as a net performance. So now I have got the net performance which gives a little margin from the gross performance. Margins are these depending upon the different stages of the flight. Now the regulator says that whenever you plan a flight from place A to B, you must consider that obstacle clearance, and the obstacle clearance is the net flight path has to clear all the obstacles on your route by the required regulatory margin. So if this net flight path is clearing all the obstacles by the required regulatory margin, obviously considering these many aircraft which was flown on different dates, since I have already given the margin, they will be able to clear those obstacles by the required regulatory margin. So we have these two mandatory performances, the gross as well as the net performance. Well, now I'm very clear about these performances, and I am safe. If their aircraft is able to, now I have got the certification, now I need to fly as an operator. As an operator, I can limit myself, or I can give an additional margin from the what it is required by the regulator. For example, okay, we say that okay, in the event of engine failure during the takeoff, the minimum acceleration is altitude is 400 feet. Okay, in case of an engine failure during the takeoff, I have to climb at least up to 400 feet, thereafter start accelerating. That is what we call it as a minimum acceleration altitude. But now if I open an airliner, I can say that instead of accelerating it at 400, I will give a little margin to my pilots. So therefore, for my airline's operation, or for your airline's operation, okay, the performance which is going to be computed, okay, that is the takeoff weight which you are going to be taking during the takeoff, considering the safety of the aircraft, instead of considering it for 400, I will consider that for a little higher altitude, that is 1000 feet. While doing so, I might have to reduce a certain kgs of weight. So that kind of a performance, what we compute for daily operations is what we call it as a operational, RATIONAL, operational performance. Most of the companies will have an operational performance which is a little stricter or a little conservative than the one which is given by the manufacturer. Once again, for an example, your aircraft might have been demonstrated by those test pilots under certain harsh conditions. For example, the maximum crosswind component which it was demonstrated for this aircraft maybe, let's say, 38 knots. Okay, but the company, if I am operating a company, I will not let my pilot fly right up to 38 knots. I may restrict the, okay, that my aircraft will not fly beyond 25 knots of cross country, sorry, crosswind component. So in this case, I'm going to be limiting my performance, considering a little extra safety involved. That kind of a performance calculation is what we call it as a operational performance. So now we have got the mandatory performance, which is required for the certification, okay, which was achieved by this demonstration flight, and I will determine the gross flight part. This gross flight part has to clear the minimum mandatory standard or the performance required. But for obstacle clearance consideration, okay, considering the variability of the aircraft, the weather, different flying technique, considering the edging of the aircraft, I have mathematically reduced this gross by 0.8 and the 1.1 percentage, okay, and they achieve this net flight path, and the net flight path or the net performance is calculated for considering the obstacle clearance. Thank you, ladies and gentlemen. That's all for today.